Okay, today we are going to start exploring equivalent fractions. So we're going to use this, but we're also going to take some things off on the side. So we're going to use these problems, but we are going to do some things on the side. So an equivalent fraction means that they are two fractions that represent the same part of a number. So meaning, for example, if you look here at these fraction bars, this 1/3, these 2/6, and these 4/12, all of them represent the same part. So it would be, for example, like if you broke up a candy bar into thirds, sixths, and twelfths, you would just need more twelfths to get the same amount of chocolate as the 1/3. So they all represent the same part of the whole. They're just broken up into different amounts of pieces. That's what's different. So same actual amount, it's just broken up in a different way. So we are going to start making equivalent fractions. So first we're going to pull out a third. And we have a bag here full of fractions that we can use. So first we're going to pull out a third. Okay? And then we're trying to go ahead and figure out some fractions that equal a third as well, but have different denominators, meaning they've been broken up into different size pieces. Just because they've been broken up into different size pieces doesn't mean they can't be equivalent at all. It just means that it might take more of those pieces, those other pieces, to equal the bigger pieces, okay? Which is totally fine. So I'm trying to pull out my sixth here. And I have 1/6 here. Okay. So 1/6 isn't going to do it, it looks like. So let's pull out another 6. There we go. Huh. 2/6. Looks like 2/6 will do it for us. Perfect. Okay. I want something else that's also gonna be there. I'm gonna pull out a 12. I feel like 12ths might be a good thing to use just because they're a multiple of 3. And so far, I'm noticing that everything here in the denominator is a multiple of 3. I really wonder if that has anything to do with the fact that these are all equivalent fractions. We'll have to keep going and see if there is a relationship there. I think there might be. Nothing in math appears to be a coincidence ever. All right, so it looks like 1/3, 2/6, and 4/12 are all equivalent. We know they're equivalent because it's the same amount. It's just more or less pieces to get there, okay? So they're all equivalent fractions, okay? 1/3 is equal to 2/6 is equal to 4/12, okay? All right, we're gonna go ahead and look at another problem that our math book has provided. And this time they're wanting us to use fourths, okay? So they're showing us some number lines. And I think number lines are a good tool when you have them. Now, you're not always going to have a number line, and it's really important to not always trust that you are capable of drawing a perfect number line, because I'm going to be honest with you, you're not. I'm not. Unless you take out a ruler and take all your time making this perfect number line, it's not really always going to be effective. But if you have number lines available, use them. So this number line has been already given to us, and it is perfectly ready to be used. So here we have this number line, and it's divided into fourths. So let's go ahead and plot 1/4 on that number line. So there's 1, 2, 3 fourths. Okay, so 1/4 is right here. All right, so now we want to find a fraction that's on the same location. Well, this one looks like it's split into 1, 4, 5, 6, 7, 8. Okay, eighths. Well, if I look straight down below, that's 1 2/8. Okay, so far it looks like 2/8 is equivalent. Okay, so I've got my 1/4 there. I'm going to put some eighths here too. Let's see, get some eighths out. Let's see, do these line up with my fraction pieces too? They do. Glorious. Okay, so 1/8. Okay, and now this one's divided into 12ths. All right, so if I go straight down, 12ths. Okay, and that's 1 2 3 12ths. All right, so let's get my 12ths back out and see if it's not only true on the number line, but with fraction bars too. There's 1/12. And see, another 12th. And a third 12th. Okay, so that looks pretty spot on. 1/4. Just a little bit. 1/4, 2/8, and 3/12. Well, they're all equal, and they're all equal on the number line. And you know what I noticed again? This, and this, these are all multiples of each other. If I list out the multiples of 4, 2 times 4 equals 8, 3 times 4 equals 12. Huh, those are all multiples. So I bet that the next equivalent fraction, I bet that it would have a 16 in the denominator. We'll have to check that soon. All right, let's go ahead now, and I want to look at this one here, looking at for a pattern. So this table here shows some equivalent fractions. It wants us to study the table and describe the pattern between the numerators and denominators of two equivalent fractions. All right, let's zoom in on here and take a look. Okay, so they're wanting us to look at the relationships. Okay, so, all right, so 3 to 6, 1 to 2. Well, it looks like, once again, these are multiples. What else do you notice? Well, one thing that I notice is that from going from here to here, that's 2 times bigger. It's also 2 times bigger on the top. That's interesting. 3 and 12, those are also multiples. Okay, so this is seeming to be a pattern. 3 to 12, well, that's times 4, and 1 to 4, well, that's times 4 too. Oh, okay. I have a feeling that there's something going on here. 4 and 8, yes, those are multiples of each other again. 4 times 2 gives me 8, and 1 times 2 gives me 2. Okay. 4 times what gives me 12? Well, that's times 3, and well, 1 times 3 gives me 12, and those 4 and 12 are multiples of each other. I think there's some sort of relationship between these two numbers. And it looks like I'm multiplying times 2 on both the top and the bottom, times 4 on both the top and the bottom, times 2 on top and bottom again, and times 3 on top and bottom again. I think that might be proof that these are equivalent fractions. So I guess I could ask myself, if the same number is multiplied on the top and the bottom to get those other top and bottom numbers, then they must be equivalent fractions. Let's test this out on number 2 here. So it says, without using fraction tiles or number lines. So put your fraction pieces away and don't look at any number lines. We need to determine whether 1/2 and 3/6 are equivalent fractions. thinking about the patterns we just talked about over here, are 1/2 and 3/6 equivalent fractions? And why or why not do you think so? Okay, so 1/2 and 3/6. Well, the patterns I was noticing was that these two were multiples. Okay, so 2 and 6, well, I know 1 times 2 equals 2, 2 times 2 equals 4, 2 times 3 equals 6. Okay, so they are multiples, yes, on that denominator, okay? Also, the other thing I noticed was that top and bottom were being multiplied by the same thing, and that showed that they were equivalent fractions. Well, to get 2 to 6, I multiplied by 3. 1 to 3, well, that's multiplied by 3 too. So yes, they are equivalent fractions. And I know this because the bottom two the denominators are multiples of each other, and because I multiplied by the same number on the top and the bottom to get those to be equivalent fractions. Okay? So we've talked about 3 methods so far. 1, using fraction bars to check. 2, using number lines if they're available. Same thing with fraction bars. 3, looking for multiples and seeing if the top and the bottom were multiplied by the same number to get that answer. I want you now to look at page 501 with me. We're going to try 2 together. So recognize whether the fractions are equivalent, write yes or no, use fraction tiles or number lines. So it's up to you how you solve this, okay? So I want you to go ahead and solve number 3 first. 2/4 and 6/12. Go ahead and solve it either using fraction tiles. Do not use number lines just because we're not able to draw a perfect number line. So either fraction tiles or the multiples and top and bottom strategies we've been talking about. Okay, so it looks like we have 2/4 and 6/12. So there's 2/4, and we're gonna go ahead and get 6/12 too. There's another 12. Make sure you are making this as well. Well, so far it looks like 3/12 will give me a 4th. So it's looking like it's gonna turn out pretty good that 6/12 are going to equal 2/4. So, all right, it looks like visually, yes, they are equal. Now let's go ahead and check when it comes to our question. Are 4 and 12 multiples of each other? Yes. Did I multiply by the same thing on the top and the bottom to get these? So 4 times 3 gives me 12, and 2 times 3 gives me 6. So yes, these are equivalent fractions. I checked it both those ways. Go ahead and look at number 4 now. 6/8 and 5/10. All right, so let's go ahead and check it. So 6/8. 1, 2, 3, 4, 5, and 6. So I've got 6/8 here. And then 5/10. All right, let's see how that turns out for us. One, two, 3, 4, 5. Uh-oh. That does not appear to be equal. Not even close. Even if my things were perfectly straight, that is not even close. Okay, so that's one way of proving that that is not even close. Okay, another thing we can do. Let's look here. Are 8 and 10 multiples of each other? No, they're not. And there's not even anything I can multiply by 8 to get to 10. Same thing with 6 and 5. So there is no way that those fractions are equivalent. Okay, so we've talked about several different ways to figure out whether or not fractions are equivalent. Using fraction pieces when you have them, using number lines if they're already there for you, and checking for multiples between the denominators and whether or not the top and bottom had been multiplied by the same thing. So go ahead and use those strategies to help yourself determine whether or not these fractions are equivalent.